ReasonConf is brought to you by our gold sponsors Ahrefs and Chain Street.
Okay, so I'm going to talk a bit about how to write reason in an approachable way, at least insofar as I figured out during the process of writing reprocessing. So I mean, reprocessing, it's like a 2D library, the 2D graphics library inspired by processing, which I discovered mainly due to wasting time on YouTube and running into Daniel Schiffman's series, The Coding Train, where he basically has like an extremely energetic presentation of processing, sort of the original graphics library in Java, and he's sort of he builds out these pretty simple projects, but totally aimed at beginners. And I wanted to get some of this creative energy accessible to new Reason devs in an easy-to-use way. So yeah, lots of credit to Daniel and all the other authors of processing and the other ports that exist. And so, okay, how do I write an easy library to use? Okay, first, I guess I'll start with making it easy to install and like cross-platform. So it's like on Linux and Mac, but also Windows, and compiles to web, and I guess there are other targets conceivably. And then do your best to document it. As a couple of people have mentioned, we could obviously do a better job of this too, but we tried a little bit. Yeah, and then it's like, okay, you got it installed. Now, what do you do with it? How do you use it? And you get into sort of API design decisions. And so the way that I went with it is, keeping it pretty unopinionated. You want to sort of expose this functionality to your users without necessarily forcing them to pick certain solutions over others, because it might depend on what they're doing. Maybe they're making like some visual art piece, or maybe they're making a game with it. And if I give too much structure, then it's going to stop them from doing what they want to do with it. And then I also sort of erred on the small side of the API. I implemented features as I needed them or as they were used, because I find that it's nicer to use a library that has a lot of sort of well-exercised functionality than use a library for which the functionality that is implemented is well-exercised, rather than using one that sort of covers a lot of the bases but in a less tested way. And so that seemed to work pretty well. And so like once it became, once I started having something that was usable, I started using it and then figuring out which parts were missing and then adding those. And then obviously there's a lot of wildcards when you're doing this. So being inspired by processing in this case helped a lot with the direction of like, okay, I picked something that I know has good properties. I can be inspired heavily by that and draw direction from that for the API. And so then I guess it gets into like, okay, now what do I do more specifically, I guess? And so there were a lot of questions that me and Ben, who was working with me on it, discussed at more length than probably one would expect. But so there's an example. So the top is actually not what you do in reprocessing. The bottom is what you do. But we considered having this API for drawing shapes that would sort of abstract all of the shapes into this one data type, and then have a unified function that you would use to draw them all the same way. And it seemed like, okay, that seems like it could be pretty cool. Like, yeah, why wouldn't we do that? And so it took a little bit of time, and we experimented with building little applications with it in each interface, even though it wasn't implemented in both interfaces. We sort of implemented against a fake library that didn't exist to see how it would work out in real life. And what we sort of realized is it adds like another concept that you have to think about before you're even drawing. And so you got to think about this rect object or this line that you're passing to shape. And so when you're teaching this to somebody new, you gotta, you want to do your first demo of like, hey, you're gonna draw a rect on the screen, and like already you gotta explain what a variant is, and they should learn that pretty soon, but maybe not like before they write their first line of code. There's also like some ergonomics issues with the first option, which made it so that we didn't want to use that. Like, we can't really do optional named args in the same way, and so it's harder to extend it or add extra functionality that you wouldn't use by default, but that you would want to maybe use in a more complex application, so it made it so it sort of grows less naturally. You could maybe get around that with, you know, hiding this variant constructor behind a function, but then, you know, now you've got a rect function, and your user doesn't know, what does this rect function do? Is it like doing some data calculation behind the scenes? Should I be caching the result of this thing and like shoving it in the state and remembering it over time? It becomes a little bit complicated, like how should I be curating this chunk of data? And so by not ever having a chunk of data there, it makes it so that you never think about that. It's not an option, so you don't need to care. And so we found that it took care of a lot of questions that now just don't even get asked because you can't do any other things. You know, there's other issues like what should be included in this. What should be included in this object too? Like, should it include the color of the rectangle, or its like position or rotation? You know, it gets pretty hairy kind of fast there. And so, in this case, even though it seemed like the first one was much more unified and clean and nice, in practice it turned out that the second one was simpler and easier to think about. And so we stuck with that. In some situations, it's hard to know like when to depart from the inspiration that you're taking. So like in processing, the way that you basically do rotations and translations is on the top here, where you're like pushing some matrix and then you sort of do a translation of it and you scale it and rotate it and translate it somewhere else, and then you draw something at 0 and pop the matrix again. And it's a bit tricky for people to figure out. And actually, this is what reprocessing does right now, and it's been consistently like the biggest pain. And so as we see more and more people use it, we see, okay, how can we make this a little bit easier to use? And we think, okay, maybe we can add like a rotation and like a rotation center sort of specification to all the draw calls, so that, you know, make them optional named parameters and things like that, so that most of the time you don't think about it, but then when you need to rotate, then you can just say rotate. And that's easy. And then you could still keep this draw push matrix stuff for the weird edge cases that this API doesn't support, but then the general case is much easier. And so I think that it's interesting to explore these concepts where you can get most of the coverage of the solution space in a much easier way, and then provide a backdoor to drop into something more complex for when you really need it. I'm confused as to why. I'm curious as to why processing itself doesn't do something a little bit easier like this. I'd be curious to talk to anybody who knows more about that, if there's anybody like that. Maybe it's like limitations at the time or something. So then there's a lot of questions that came up when this was first published, and like I thought about too, because, you know, we're in a functional language. Should this be more functional API? Or should it be like more immutable or something like that? So I mean, when it comes to, we'll go through them one by one, I guess. When it comes to the first one, like your state when you're writing a reprocessing app is pretty immutable. So you can make your data manipulation as immutable as you want. And really, like most people that we've seen writing it are writing functional manipulations of the state, and then they're drawing imperatively to the screen at the end. And so in practice, it ends up being pretty fine, and you get a lot of the benefits of you know, the functional programming stuff, even though this API is, like the actual drawing API is more or less imperative or declarative, depending on how you look at it. Yeah, and then you know, we tried monads, but you know, for some reason beginners weren't catching on. Couldn't figure that one out. I mean, we told them to read the MLI, but didn't help. So basically, the thing that I gained from it was like keeping the things that your user needs to know in order to use your library to a minimum, so that they can use your library to solve the problems that they actually need to solve. And actually, like the hard problems when using reprocessing are like, how do I write my game, not how do I use reprocessing? Or at least that's the point. And then whether or not that was successful, like, I mean, I hope so, but like, I guess some people have used it. We like to put on our README like a list of all the stuff that we know about that people have written with it. Obviously, if your thing isn't there, you should put it there because it makes the slide better. And it also helps like more people think that they have it in themselves to actually build something, because a lot of people like want to make something creative but think that they don't have the abilities, and I think that's too bad. And we should make it easy. That's it.